Hi, this is Janakireddy Dubbaka, Physics Rapid Revision for Neet and Mains. This is lecture number 2 from Fields and Charges. See, in this lecture, we are going to discuss about equilibrium of charges. So, equilibrium of charges, there are three types of equilibrium: stable equilibrium, unstable equilibrium, neutral equilibrium. A charge initially in equilibrium position and displaced by small distance, if the charge tries to return back to the same equilibrium position, then this equilibrium is called a stable equilibrium. For example, general observation, this is one hemispherical surface, bowl. A ball is placed at the bottom of that bowl. If you displace this ball, again the ball come back to the original position. This type of equilibrium is called a stable equilibrium. Unstable equilibrium, if the charge is displaced by small distance from its equilibrium position and the charge has no tendency to return to the same equilibrium position, instead it goes away from the equilibrium position, then this equilibrium is called unstable. See here, now the ball is like this. Here it is at rest equilibrium. If you displace like this, it will never come back to the initial position. This is called unstable position. Neutral equilibrium means if a charge is displaced by a small distance and it is still in equilibrium condition, then it is called neutral. For example, here is the body stable equilibrium. When you displace to here, again at that place it is in equilibrium. These are called equilibrium. There are two types of equilibrium: stable, unstable, and neutral equilibrium. For example, see, stable equilibrium particles only can oscillate in simple harmonic motion. See, in our problems, for example, if it is a stable equilibrium, what is its time period? See, in which cases it is in equilibrium and stable and unstable, if the charge is fixed, if the charge is free. See here, this is a case 1. Charge Q1 and charge Q. These two are fixed charges. Fixed charges. If you place a third charge Q, at what distance, or is it between the charges or outside the charges, the charge is in equilibrium. For example, if you consider, if you place a third charge Q, this is the positive charge, therefore this positive charge repel in this direction, and this positive charge repel in this direction, net force is equal to 0. For example, if it is a negative charge, this positive charge attract this negative charge, and this positive charge attract this negative charge. Again, if these two forces are equal, the third charge is in equilibrium. Therefore, the equilibrium of third charge, whatever may be its sign, is it positive or negative also, it is in equilibrium. And it does not depends on magnitude also. Why? Because these two charges are fixed. Therefore, fixed charges means if the magnitude is very greater than, then it does not pull these charges. Therefore, for equilibrium of these charges, like this is third charge. In this case, for like charges, therefore this is positive, this is positive, this is negative, this is negative. If like charges, the third charge should be placed in between the charges at a distance x from the charge having smaller magnitude. See, formula is x is equal to d by square root of q2 by q1 plus 1. Here q2 should be greater than q1, and this distance is from the charge which is having smaller magnitude. This is a case 1. Next, case 2. Here one is a negative charge, another one is a positive charge. For example, if you place a third charge in between this one, this positive charge repel in this direction, this negative charge attract in this direction, therefore forces are in same direction, therefore net force is not 0. Therefore, if you take outside of the charges, this positive charge repel in this direction, this negative charge attract in this direction, therefore net force is 0. Therefore, unlike charges, the third charge should be placed outside of the charges along the line joining the charges. That is important. Along the line joining the charges at a distance x, that x is equal to d by square root of q2 by q1 minus 1. Here q2 greater than q1. Here also q1 and q2 are fixed charges. Therefore, when corner charges are fixed, then middle charge means third charge. For like charges, it should be placed in between the charges. Unlike charges, it is placed outside of the charges. Here formula -1 for unlike charges, +1 for charged. +1 for like charges. And here the third charge sign does not matter. And also magnitude also does not matter. This is case 1 and case 2. And see case 3. See, this one is fixed charge. This one also fixed charge. Now, these are the two equal charges. For equilibrium of third charge, this should be placed in between the charges, at midpoint of the charges. For example, this is A, this is A, midpoint of the charges. Now it is in equilibrium. Is it a stable equilibrium or unstable equilibrium? For example, if you consider this charge as a positive charge. If this positive charge displaced through small distance x here. See, here this charge I am taking left charge, this charge is taking right charge. Here it is positive charge, therefore this positive charge repelled by this one, therefore this is the force by left charge and this is the force by right charge. See here, left charge distance is more when you compare to right charge. See here, left charge distance is this one and right charge distance is this one. Force is inversely proportional to distance. Therefore, this is the less distance. Therefore, right charge will exert more force. Therefore, here net force is in this direction. F net means when a charge is displaced like this, but net force is again this one towards equilibrium. Therefore, this charge again comes to the initial position. Therefore, now this plus is stable equilibrium. For example, it is a negative charge. It is a negative charge. Here, negative charge is attracted by left charge. This is Fl. And this negative charge is attracted by right charge, Fr. Here, Fr is greater than, therefore, net force is in this direction. If you disturb this charge towards right, again it moving towards further towards right, therefore it is unstable. See here, corner charges are plus plus. If middle charge is plus, it is stable equilibrium. Corner charges are plus plus, middle charge is negative. This is unstable equilibrium. This is stable and unstable equilibrium. Therefore, here plus charge is stable equilibrium. Plus charge is stable equilibrium means it oscillates in simple harmonic motion. Then what is it? Is a time period that we have to find out. See here. See, this is negative charge. This is negative charge is unstable equilibrium. Now, for stable equilibrium, we have to find out what is the time period. See here. This is a charge Q. This one is left charge due to left force due to left charge, and this one is force due to right charge. Fr greater than Fl, therefore net force is in this direction. See, net force here Fr greater than Fl, but generally we can consider rightward force is positive, leftward force is negative. Therefore, net force I am taking Fl minus Fr. Fl minus Fr. See here. Here this distance is A and this distance is A. This one is X. Therefore, this distance becomes A minus X and this becomes A plus X. Net charge, left charge, that is K into Q. This distance is A plus X whole square and minus this is K into Q A minus X whole square. Here F net is equal to, I am taking common K Q into Q. Here LCM is A square minus X square whole square. This becomes A minus X whole square minus A plus X whole square. Therefore, F net is equal to K into Q. This is A minus B whole square minus A plus B whole square. This is minus 4AB minus 4AX by A square minus X square whole square. See here, x is very much less than a, then x can be neglected. Therefore, f net is equal to k into q minus 4ax by, here x can be neglected, a to the power of 4. This becomes minus k into q 4ax by a to the power of 4. Here a cancel. Therefore, f net is equal to minus of k into, this is 4 kq by a cube into x. This is nothing but restoring force. Here restoring force is directly proportional to displacement in opposite direction. Therefore, the oscillations are in simple harmonic motion. Here f net means ma, that is equal to minus 4kq by a cube into x. Therefore, a is equal to minus 4k q into q by m a cube into x. When you compare this one with a particle in SHM, that is equal to a is equal to minus omega square x. Therefore, instead of omega square is equal to 4kq by m a cube. Therefore, omega is equal to square root of 4kq by m into a cube. This is angular velocity. From this angular velocity is 2 pi by t. This becomes square root of 4k q into q by m a cube. Therefore, t is equal to 2 pi into square root of m a cube by 4kq. Therefore, here k means 1 by 4 pi epsilon naught. This is one type of equilibrium. For example, another case. Here, this is a charge q, this is charge. These are also fixed charges. Here is a third charge. See, here I am taking this charge plus q. If this plus q is displaced perpendicular to the line joining the charges, this is plus q. Therefore, this plus q repel this in this direction, and this q also repel in this direction. Therefore, f net is in upward direction. We are displacing the charge in upward direction. Again, net force is in upward direction. Therefore, it will never come back to initial position. This is nothing but unstable. See here, this middle charge is negative. When you displace perpendicular to this one, this positive charge attract this one. This positive charge attract this one. Therefore, net force is downward direction. Means your charge is displaced upwards. Net force is downwards. Therefore, again it come back to original position. Therefore, here, if the corner charges are plus and plus, middle charge is plus, it is unstable. If the corner charges are plus, middle charge is negative, this is stable. Therefore, for stable equilibrium, this charge can oscillate in up and down direction. Then we have to find out what is its time period. See here. See, here this is the force F and this is the force F. Here is angle. This force can be resolved. F cos theta, this is F sin theta. This one also F cos theta, F sin theta. These components F sin theta gets cancelled. Therefore, net force is equal to, therefore, F net is equal to 2F cos theta. But we are displacing a upward direction in this direction, but net force is downward. Therefore, I am taking minus. Therefore, here F is equal to K into Q by, this distance is square root of A square plus Y square. Therefore, A square plus Y square root whole, this becomes. And cos theta is equal to Y by square root of A square plus Y square. Therefore, F net is equal to minus 2 into F means K into Q by A square plus Y square into cos theta means Y by square root of A square plus Y square. This becomes F net is equal to minus 2 k into q y by a square plus y square whole to the power of 3 by 2. Here also y less than a. Here y can be neglected. Therefore, f net is equal to minus 2k q into q y by, here y can be neglected. This becomes a cube. This is equal to f net. F net, I'm taking f net is equal to ma, that is equal to minus 2k q into q y by ma cube. This is equal to minus of 2k q into q by ma cube into y. Here also this is after that m. Therefore, here also acceleration is directly proportional to displacement in opposite direction. Therefore, this term becomes omega square. Therefore, omega square is equal to 2k q into q by ma cube. Therefore, omega is equal to square root of 2kq by ma cube. Therefore, this is angular velocity. Then time period is 2 pi by t. Therefore, t is equal to 2 pi into square root of ma by 2kq. This is a time period. Here k is equal to 1 by 4 pi epsilon naught. See, this is the time equilibrium and stable equilibrium and unstable equilibrium. Here another important thing, this force is maximum. See, when you differentiate this force and equate to 0, here we can get y is equal to plus or minus a by root 2. So, y is equal to plus or minus a by root 2. See, very important. If it is a by root 2. For example, total distance is considered a. In this case, y is equal to plus or minus a by 2 root 2. Therefore, when a charge, third charge is displaced along the perpendicular bisector of two charges, then force will be maximum when y is equal to plus or minus a by root 2. See here, these are the free charges and separated by a distance 2a. As both free charges are identical, we have to place, for example, third charge. Third charge, but here these are free charges. Free charges means not these two are fixed. Both systems should be in equilibrium. System should be in this charge also equilibrium, this one also equilibrium. If you place third charge, that one also equilibrium. See, these are like charges. Therefore, third charge should be placed in between this one. The position of the charge can be find out using x is equal to d by square root of q2 by q1 plus 1. But here there are similar charges and equal magnitude. Therefore, the third charge should be placed exactly in between the charges. Therefore, here this is third charge A. But here sign can be decided. For example, see, this is the charge exert. If you are here, you have to find out the net force on corner charge. This charge exert a force in this direction positive. If it is positive, this one also exert a force in this direction. Net force never becomes 0. Therefore, the center charge should be negative. In that case, it will exert a force here. Therefore, then we have to find out what is the magnitude of this charge. See here. Here the third charge should be placed at the midpoint. Why? Because corner charges are same charge of magnitude. Here take any corner charge that should be in equilibrium. For this corner charge, another two charges are there. This positive charge exert a force in this direction. This negative charge exert a force in this direction. Then only it will be equilibrium. See, this charge exert a force F1 and this charge exert a force F2. These two are unequal. Then this corner charge, also middle charge, means total system is in equilibrium. Therefore, F1 is equal to K into Q square. But total distance is here 2a, 4a square. And the second one, F2 is equal to this charge and this charge, K into small q into q by this distance is A square. Here F1 is equal to F2, therefore K q square by 4A square, that is equal to K into q by A square. So here this K gets cancelled, A square Q gets cancelled, Q by 4 is equal to Q. Therefore third charge should be Q by 4, but it negative charge, then only it will resultant force on net third charge, corner charge is 0. Therefore it is minus Q by 4. See, take another example. Here, these are the two charges, plus 8 microcoulomb, 2 microcoulomb. See here, these charges are not equal. Then the third charge should be placed in between the charges, but where you have to place? Why? Because this is plus, like charges, third charge should be in between the charges. But its position can be decided by x is equal to d by square root of q2 by q1 plus 1. Here the total distance is 30 centimeter. Therefore 30 by q2 is 8. This one is 2 plus 1. Therefore 30 by 8 by 2 4. 4 root 2. 2 plus 1 3. This is 10 centimeter. Therefore here, see, for example, this is the charge q. This should be 10 centimeter. This should be 20 centimeter. Therefore the position of the charge can be decided by this formula. After that, equilibrium of the system means the corner charge should be in equilibrium. See, this charge exert a force in this direction. If it is a positive charge, this one also exert in same direction. Therefore net force is not 0. Therefore the middle charge should be minus. In this case, this is the force F1 exerted by Q1 and this is the force F2 exerted by this charge. Therefore here F1 is equal to F2. F1 is K into 2 into 8 by total distance is 30 square. Therefore this is 900 and F2 is K into this one is charge Q and this one is 8 by this distance is 20 square 400. Therefore this 8 gets cancelled, K gets cancelled, 2 zeros gets cancelled. Therefore 2 by 4 is equal to Q by 4. This is 2, sorry, here 2 by 9 is equal to Q by 4. Therefore Q is equal to 8 by 9. Q is equal to 8 by 9, but this charge is negative. Therefore minus 8 by 9 microcoulombs. This you have to find out. This is a equilibrium of charges. See, equilibrium of charges, stable or unstable. If the corner charge is fixed, if the corner charge are not fixed. If the corner charges are not fixed, the third charge position should be decided by x is equal to d by square root of q2 by q1 plus 1 or minus 1 depends on the corner charges sign. And also, then I have to take the net force on corner charge should be 0. In that case, we can find out the magnitude of third charge and also its sign. This is about equilibrium.